Hello everyone and welcome back to Vidyalankar. My name is Anuj पवार और जैसे कि लास्ट दो वीडियोस में हमने सॉइल मैकेनिक्स के दो इम्पोर्टेंट चैप्टर्स देखे थे, एक था कंसोलिडेशन और एक था शियर स्ट्रेन. सिमिलर वे में आज हम एक नया इम्पोर्टेंट चैप्टर देखेंगे, दैट इज स्ट्रेस डिस्ट्रीब्यूशन. ये चैप्टर इसलिए इम्पोर्टेंट है क्योंकि 2020 में इसके ऊपर कोई भी क्वेश्चंस पूछा नहीं गया था, तो 2021 में इसके ऊपर क्वेश्चंस पूछने के बहुत चांसेस है. सो फॉर मोर अपडेट्स एंड इंफॉर्मेशन यू कैन click on a subscribe button and a bell icon. So moving with this chapter, that is stress distribution, first we'll list out कि फॉर्मूले कौन कौन से हमें यूज करने हैं. तो यहाँ पे अगर देखोगे तो फॉर्मूले में बेसिकली इन दिस चैप्टर यू टू यूज वन थ्योरी. द नेम ऑफ दैट थ्योरी इज नोन एज अ Boussinesq theory. So basically you have to use this Boussinesq theory, and using this theory you have to find out the stress at different depth. There is an alternate theory also, that is a Westergaard theory is also used, but the maximum problems will be asked from this theory. So if you have to find out the stress at any depth, so it is given as a sigma z. That formula will be Kb into Q by Z square. So this theory we are applying for the point load. So whenever you are applying the point load, that point load is Q. At which depth you are applying, that will be your Z, and Kb is your Boussinesq coefficient. And that Boussinesq coefficient, that Kb is equals to 3 divided by 2 pi in bracket 1 upon 1 plus R by Z bracket square to the power 5 divided by 2. So basically this is the Boussinesq coefficient. So here if you see that R is your radial distance and Z is the depth at which you are finding out the stress. So if you know that Boussinesq coefficient, if you know the load, and for at what depth you have to find out that stress, if you know that, you can find out the stress at respective point. So similar way, if you will see that if my point of load is in the same line of action, at that time your R value is 0 and your Boussinesq coefficient, that is Kb, is directly you can use as a 0.4775. This is the important one, as you can remember directly the values, so that at the time of solving you can use this one. So apart from this point load and the Boussinesq theory, there are some different you can say the loading conditions also there, such as firstly as a uniform line load. So if there is a uniform line load, so at that time, for example, this is a surface and this is a uniform line load which is acting. So at certain depth, suppose assuming as a x and at depth as a z. So if such a uniform line load is acting at that time, if I have to find out the stress at this point, point P, so the formula for that given is sigma z is equals to 2q divided by 2 pi in bracket 1 upon 1 plus R by Z bracket square and whole bracket square. So directly you have to just identify the type of load and accordingly you have to use the load. The another way, whenever you have to find out the vertical stress and the distribution below as a uniformly circular foundation. So if this is my circular foundation having a diameter d and the load is acting on its peripheral, so at that time if I have to find out a stress at certain depth as a z, at this point as a p, so the stress distribution formula, that sigma z is given as 2q divided by 2 pi, for this vertical one, that formula is given as a 1 minus 1 upon 1 plus R by Z bracket square bracket complete to the power 3 by 2 and whole bracket should be multiplied with the q. So q is your this small q. So sometimes they will give you a point load. So if they have given as a point load, you have to convert it into the small q. So अगर मुझे small q में convert करना है, that capital Q, that is point load divided by the area of the footing you have to do. So you will get the small q value. Here R is your radius of that footing. So ये अगर मेरा diameter रहेगा तो ये small r मेरा radius of the footing रहेगा, and Z कौन से depth पे आपको find out करना है, that value you have to use one. And the last one that also you can remember for this one, that whenever the vertical stress you have to find out due to the strip load. So whenever there is a strip load is acting, So at that time, if you have to find out the, you can say the stress at different location, so how you can find out? So if suppose this is my strip load is acting, and if I have to find out the point of location is here. So what you have to do? You have to join the first corner point. You have to join both corner points and the center point. So the angle which is made by this is denoted as a theta. The angle which is made by the angle is this one is your considered as a beta, and this considered as a depth as a z. So in such a condition, you have to find out the stress. So the formula will become as a sigma z is equals to q divided by pi in bracket theta plus sine theta into cos 2 beta. So this formula will be used for finding out the vertical stress due to the strip load. So you have to find out basically बॉसिगनीस थ्योरी से पॉइंट लोड से किस तरह स्ट्रेस निकाल सकते हो, अगर यूनिफॉर्म लाइन लोड लगता है तो किस तरह निकाल सकते हो, अगर सर्कुलर फाउंडेशन के हिसाब से है तो किस तरह निकाल सकते हो, अगर स्ट्रिप लोड लगता है तो किस तरह निकाल सकते हो. But if you'll see with the previous question papers and all that, the only important theory is this one, that is a Boussinesq theory. So you can remember this formula and this coefficient, that will be sufficient for this chapter. So we'll start one by one the numericals, those are asked. So as in the beginning I have already said that कि ये 2020 में एक भी इसके ऊपर क्वेश्चन पूछा नहीं था. सो देर इज अ मैक्सिमम चांसेस कि 2021 में इसके ऊपर क्वेश्चन पूछेंगे. सो मूविंग टू द फर्स्ट क्वेश्चन, दैट इज 2019 आफ्टरनून सेशन फॉर द 2 marks. A 2x4 meter rectangular footing has to carry a UDL of 120 kPa. So if I will just draw a simple diagram as a rectangular footing, I am showing this as a width that is 2 meter, and on this is a length that is assuming this as a 4 meter, that is given as per the dimension. The dispersion, that is load dispersion, is given as a 2:1 vertical. So basically if my load is dispersed, so this load dispersion they have given as a 2 vertical is to 1 horizontal. So they have given in this one, and they have asked to find out the increment in the vertical stress at a depth of 2 meter below the footing. So basically they have asked कि 2 मीटर डेप्थ पे, अगर मैं ये डेप्थ अगर 2 मीटर कंसिडर करता हूँ तो ये डेप्थ पे मेरा स्ट्रेस कितना रहेगा, ये उन्होंने पूछा है. सो इफ आई टू फाइंड आउट दैट वन, एज वी नो दैट इफ आई टू फाइंड आउट द स्ट्रेस, सो स्ट्रेस इज नथिंग बट लोड डिवाइडेड बाय एरिया. सो यहाँ पे जो एरिया हमें कंसिडर करना पड़ता है वो हमें डिस्पर्स्ड एरिया कंसिडर करना पड़ता है. तो अगर मैं डिस्पर्स एरिया कंसिडर करता हूं तो इफ आई विल जस्ट एक्सटेंड दिस लाइन एंड दिस लाइन, सो ये जो डिस्टेंस है वो मेरा 2 मीटर ही रहेगा. एज दिस इज अ वर्टिकल डेप्थ इज 2 एंड द डिस्पर्शन इज गिवन एज 2 वर्टिकल इज टू 1 हॉरिजॉन्टल, तो ये बाय डिफॉल्ट आपका ये हो जाएगा 1 मीटर और ये हो जाएगा आपका 1 मीटर. सो मेरा जो नया विड्थ आएगा वो कितना आ जाएगा, 4 मीटर आ जाएगा. सिमिलरली इफ आई विल गो विद द सेम एज अ लेंथ, तो लेंथ ये डिस्पर्शन एंगल में यहाँ पे 1 मीटर रहेगा, ये लेंथ 4 मीटर एज अ कंसिडरेशन एज इट इज रहेगा, एंड यहाँ पे 1 मीटर रहेगा. सो मेरा जो नया लेंथ रहेगा वो नया लेंथ कितना रहेगा, 6 मीटर रहेगा. सो यहाँ पे अगर आप नया एरिया निकाल रहे हो जो कि आपका डिस्पर्स्ड एरिया है, वो क्या हो जाएगा, B इंटू एल, जो कि आपका नया एरिया रहेगा 4 इंटू 6. The next parameter is finding out the load. So they have given the small q value. So basically load is nothing but your capital Q value. So capital Q by the dispersed area you have to consider, but they have given here as a small q because it is a kilonewton per meter square. So you can by just looking at the figure also you can identify that. So if I have to convert into the capital Q, I have to multiply with the area, but I am applying the load here, so I will definitely consider the area of this section only. So top पे जो मेरा area है जो कि आपको 2/4 का दिया है वही मैं कंसिडर करूंगा. तो यहाँ पे आपका हो जाएगा स्मॉल क्यू इंटू एरिया ऑफ द फुटिंग डिवाइड बाय द डिस्पर्स्ड एरिया. सो स्मॉल क्यू इज गिवन एज 120, एरिया ऑफ द फुटिंग इज 2 मीटर बाय 4 मीटर होल डिवाइड बाय माई डिस्पर्स्ड एरिया इज 4 इंटू 6. So 4 get cancelled, 2 1s are 2 3s are 3 and 4. So it is basically it is coming to be 40 kPa. So my stress at a depth of 2 meter with this dispersion as 2 is vertical is to 1 horizontal, my value is coming to be 40 kPa. So this is the question which is asked for the 2 marks in the 2019 in the afternoon session. So we'll moving to the next question, that is in 2019 in the morning section. There is also one question which is asked for 2 marks. So here the concentrated load. So capital Q value here is given as a 500 kilonewton on which is applied on an elastic half space. The ratio of increase in a vertical normal stress at depth 2 meter and at 4 meter along the point of loading. Whenever we are applying the point that loading in terms of point of application, it means your R value is 0. इसका meaning ये है कि suppose this is my surface, in if I am applying the load here as a Q and I am finding out certain at depth Z, I am finding out some certain stress at depth Z, but not in a radial direction or not in some horizontal direction. So ये जो मेरा x डायरेक्शन का जो डायरेक्शन और जो r का वैल्यू है वो यहाँ पे 0 दिया है. So and as we have noted in the formula itself, whenever your r by z ratio is 0, your Bossik's coefficient, that is Kb, is 0.4775. So basically what they have asked here, so using the Bossik's theory they have asked to find out the ratio of स्ट्रेस एट 2 मीटर पे कितना रहेगा और स्ट्रेस एट 4 मीटर पे कितना रहेगा. तो यहाँ पे स्ट्रेस एट 2 मीटर पे कितना रहेगा डिवाइड बाय स्ट्रेस एट 4 मीटर पे कितना रहेगा, ये उन्होंने क्वेश्चन पूछा है. सो एज वी नो दैट स्ट्रेस बाय यूजिंग द Bossik's theory, so whenever the point of load of application is on the same direction, your formula become as a 0.4775 into Q by Z square. So you can refer the formula list also, in that also you can find out that. So ये 2 मीटर के लिए क्या रहेगा और 4 मीटर के लिए क्या रहेगा, उनका रेशो लेना है. So if I will put for the 2 meter, it is coming to be 0.4775. Q value is 500 divided by Z square. For the 2 meter it is 2 square divided by 0.4775 into 500 divided by यहाँ पे Z रहेगा 4 का square. So basically ये 4 square by 2 square रहेगा, that is 16 by 4, that is equals to 4. So that ratio would be your 4 for this numerical. So this is a numerical which is asked in the 2019 for 2 marks. Moving to the next question, the question 3, that is asked in 2018 for 1 mark. So they have given the different statements and one of the statement is from this state distribution theory. So first statement they have said here, when the water content of soil lies between the liquid limit and plastic limit, the soil is said to be in plastic state. So basically here they have asked which statement is not correct. So we have to identify this statement कौन सा गलत है. So if you know that Atterberg chart, so from that chart if you will identify which is plot actually between the water content versus the volume. So this will be your liquid limit, plastic limit and shrinkage limit. This will be your liquid state, plastic stage, semi-solid stage and solid stage. So the statement is given here as the water content of soil lies between liquid limit and plastic limit. So ये है मेरा liquid limit और ये है मेरा plastic limit. So इन दोनों के बीच में का जो soil है वो soil मेरा कौन सा है, plastic state में रहता है. तो अगर ये मेरा plastic state में है उन्होंने बोला है तो ये statement मेरा अभी ये correct है. Secondly, they have said that the Bossik's theory is used for the analysis of stratified soil. So basically stratified soil is nothing but डेप्थ के हिसाब से सॉइल की प्रॉपर्टीज अलग अलग होती है. बट अगर आप Bossik's theory के एजम्पशंस में देखोगे तो वहां पे उन्होंने बोला है सॉइल मस्ट बी होमोजीनियस, मतलब आपके सॉइल के प्रॉपर्टीज हर डेप्थ पे सेम रहने चाहिए. सो बेसिकली ये स्टेटमेंट यहाँ पे रॉन्ग है, जो कि आपको यहीं पे इसका आंसर मिल जाता है. Third one is given as the inclination of stable slope in cohesive soil can be greater than angle of internal friction. So basically it is a true statement that theta value is greater than the friction value as a phi. तो ये भी आपका correct statement है. And the last statement is given as a for saturated dense fine sand after applying the overburden correction, if the standard penetration test value exceed 15, the dilatancy correction is to be applied. So basically dilatancy correction जो रहता है, that N2 value जो रहता है, that is given as per the formula, that is 15 plus 1 half N1 minus 15. So basically ये जो N1 रहता है, N1 is nothing but your overburden correction से जो SPT नंबर आता है वो है. तो वो नंबर अगर मेरा 15 से ज्यादा रहेगा, then and then only this quantity दिस क्वांटिटी विल बी योर पॉजिटिव साइड, क्योंकि ये 15 से ज्यादा रहेगा तो ही ये पॉजिटिव रहेगा, एंड देन यू कैन ऐड इनटू द 15 एंड यू विल गेट द वैल्यू ऑफ N2 विच इज मोर देन 15. सो बेसिकली N2 वैल्यू आपका 15 से ज्यादा ही रहना चाहिए, तो इसके हिसाब से ये करेक्शन जो है वो हम अप्लाई करते हैं. दैट्स व्हाई दिस स्टेटमेंट इज ऑल्सो करेक्ट वन. So this is a question which is asked in terms of statement for the 1 mark. Moving to the next question, that is question number 4 in 2017 in afternoon session for the 2 marks. Consider a square shaped area जो कि आपको दिया है ABCD and the on the ground with the center as M. तो इसका center point दिया है आपको M दिया है. As shown in figure, the 4 concentrated vertical load of 500 kilonewton are applied, 5000 kilonewton are applied. So हर कॉर्नर पे 5000 kilonewton का लोड उन्होंने अप्लाई किया है. The vertical stress increment in kPa up to the 1 decimal place due to this load according to the Boussinesq equation. तो Boussinesq equation से at 5 मीटर डेप्थ पे कितना स्ट्रेस आएगा ये उन्होंने पूछा है. So by looking at the diagram you can see that it is a symmetrical one. So if you will find out for only a single block, you can multiply with the 4 and you can find out for the rest one. So if I will consider this block, so ये block अगर मैं consider करता हूँ जो कि मेरा ये block है, assuming that it is symmetrical one as it is mentioned in the figure. So ये मेरा center point है M और यहाँ इस corner पे मैंने load लगाया है as a 5000 kilonewton. As distance this is a 4 मीटर, तो ये मेरा हो जाएगा 2 मीटर, ये मेरा हो जाएगा 2 मीटर. तो अगर मैं इसका रेडियल डिस्टेंस निकालता हूं तो बाय डिफॉल्ट ये मेरा क्या हो जाएगा, एज पर द पाइथागोरस थ्योरम दैट योर आर वैल्यू इज रूट ऑफ 2 स्क्वायर प्लस 2 स्क्वायर, जो कि आप लिख सकते हो 2/√2. सो मेरा आर वैल्यू आएगा. जेड कितने डेप्थ पे निकालने के लिए बोला है, 5 मीटर डेप्थ पे उन्होंने निकालने के लिए बोला है. तो वी नो दैट एज पर द बॉसिग्नेस थ्योरी सिग्मा जेड इज इक्वल्स टू KB इंटू क्यू बाय जेड स्क्वायर. KB इज योर बॉसिग्नेस कोएफिशिएंट, तो हम बॉसिग्नेस कोएफिशिएंट फर्स्ट फाइंड आउट करेंगे. KB क्या रहता है 3 बाय दैट इज 3 डिवाइड बाय 2 पाई इन ब्रैकेट 1 अपॉन 1 प्लस R बाय Z ब्रैकेट स्क्वायर टू द पावर 5/2. तो ये मेरा R का वैल्यू यहाँ पे रहेगा मेरा 2√2 रहेगा, Z का वैल्यू यहाँ पे मेरा 5 मीटर रहेगा. सो यूजिंग दिस यू कैन फाइंड आउट द KB. सो ये मेरा एक ब्लॉक का आएगा, ऐसे मेरे 4 ब्लॉक है. दिस इज फर्स्ट, सेकेंड, थर्ड, फोर्थ. सो व्हाट आई विल डू, आई विल जस्ट मल्टीप्लाई विद द 4. तो यहाँ पे मेरा क्या हो जाएगा 4 टाइम्स KB इंटू क्यू बाय जेड स्क्वायर. एज क्यू आई नो दैट इज अ 5000 किलोन्यूटन. डेप्थ मुझे पता है, मैं 5 मीटर पे निकाल रहा हूँ तो ये 5 स्क्वायर हो जाएगा. KB इस फॉर्मूले से आपने ऑलरेडी फाइंड आउट किया है. वी आर मल्टीप्लाइंग 4 जस्ट बिकॉज इट इज अ सिमेट्रिकल 4 blocks. So if you'll go with that, you can find out the value for the stress, and that stress is coming to be that sigma z is coming to be 190.8. तो ये आपका 190.8 kPa आ रहा है. So near around option if you'll see that here is option A that you can select, that is 191.36. So this is the question which is asked in 2017 for 2 marks. Moving with the last question, that is 2017 for morning session for the 2 marks. So if you will see here the same question which is asked in 2019 for afternoon session. So basically UDL load that is applied as a 500 kilonewton per meter on the ground surface. The Boussinesq theory, the ratio of vertical stress at depth 2 meter to the 4 meter as right below the line of loading. तो जब line of loading के नीचे रहता है तो आपका R by Z का वैल्यू 0 रहता है, जिसके हिसाब से आपका जो Boussinesq कोएफिशिएंट रहता है वो 0.4775 होगा. सो इसके हिसाब से सिग्मा जेड एट 2 मीटर डिवाइड बाय सिग्मा जेड एट 4 मीटर अगर मैं निकालता हूं, सो दैट विल बी कमिंग्स टू बी जेड दैट इज यहाँ पे 4 स्क्वायर डिवाइड बाय 2 स्क्वायर होगा, जिसका आंसर हमने ऑलरेडी निकाला था 4 वैल्यू जो कि यहाँ पे उन्होंने मेंशन किया. सो बाय कंक्लूडिंग विद दिस वन हम ये कंक्लूड कर सकते हैं कि इस बार जो क्वेश्चन आने के चांसेस है, so that will be the only important theory is the Boussinesq theory. So you have to only remember the one theory, that is Boussinesq theory. So in that you have to find out the stress at different section, or you can say that at different depth, and that is nothing but KB into Q by Z square. सो यहाँ पे आपका Z है डेप्थ, Q है आपका पॉइंट लोड एंड KB इज बॉसिगनीज कोएफिशिएंट. So as in 2020 there is no question on this redistribution theory, so it is a very expected question in 2021 with this one. And make sure that अगर बॉसिगनीज थेरीज को अल्टरनेटली वेस्टरगार्ड थेरी से भी स्ट्रेस निकाला जाता है, सो दैट ऑल्सो यू कैन रिमेंबर. एंड दैट R by Z value, when that R by Z value is equals to 1.52, that R by Z value is equals to 1.52, at this theory, at this ratio, that Boussinesq theory as well as Westergaard theory gives me the same result. तो in case of statement if they have asked, so आपको पता रहना चाहिए ये R by Z का रेशियो जब 1.52 रहता है तो Boussinesq theory as well as Westergaard theory दोनों theory आपको same result देते हैं. So if you like this video, you can like, you can subscribe, and for more updates you can click on our bell icon. And अगर किसी को कुछ भी डाउट है तो you can just comment on the comment section. Thank you.